I'm Cecelia Martinez. I'm a developer advocate for Appflow here at Ionic. Appflow is the mobile DevOps platform built by Ionic. You can also find me on Twitter and GitHub, various platforms at Cecelia Creates. So if you are interested in following for additional resources or checking out what I'm working on, feel free to reach out to me there. Let's talk about micro frontends for mobile and just recap some of the benefits that are involved with that. So with mobile micro frontends, like with regular frontends, micro frontends, teams can build and ship in parallel. You also get granular control for different levels of the application. You can reuse features and content, what we call micro apps, across apps and platforms. So you can build it once and then you can use it for web, iOS, Android, or any other platforms that you may be deploying to. These are, again, similar to the benefits that you may see with micro frontends, but specifically applied to mobile. We like to say that mobile micro frontends can speed up development and give your team more velocity during the development process. But on the flip side, deployments can slow you down. Mobile deployments are a much more complex beast than web deployments are. And when you introduce micro frontends to that deployment strategy, it can become more complex. So in order to ensure that you are getting the most out of your micro frontend strategy and leveraging all the benefits that are available to you, it is critical that you have a defined update strategy in order to have successful mobile micro frontends. And that's what we'll be talking about today. So I do want to throw out a question to the chat. What are you hoping to learn from today's session? So feel free to take a minute here and pop in the chat anything specific that you'd like to learn today about updating mobile micro frontends. Okay, yeah. Thanks, Vanessa. Initial idea of how micro frontends works on mobile, how micro frontends can modernize our applications. Great, thank you for that, Nate. And I understand too that based on the poll results, we have a lot of people here who are brand new to mobile micro frontends, and so you may not necessarily know what you need to learn yet, which we will be covering as well. Awesome. So some questions around effectively using the same functionality in both mobile and web app. How can we use micro frontends with native code like Swift and Kotlin to deliver the best experience possible? Great, love that, Jerry. And how to deploy and scale in production. Awesome. So thank you so much for those answers. We will definitely be covering some of that and more in today's session. So the agenda for today's session is, the goal here is to give you essentially a blueprint of everything that you need to take into consideration when defining out your mobile micro frontend update strategy. Whether you are just considering implementing the strategy for mobile micro frontends or whether you're currently in the process, you may or may not, you may be thinking more about implementation from the development perspective and less from the deployment perspective. That's something that we tend to think about later. So I'd like to provide you with all of the organizational considerations that you'll need to think about, infrastructure and architectural considerations, as well as process considerations, point by point, that will essentially provide you with a framework for defining out your strategy. As Luca and Vivek had mentioned, and as it's come up as a theme across many of these sessions, is mobile micro frontends is a technological solution, but it's also very closely tied to organizational structure. So we'll talk about not just the technical implementation details, but also across the business. Finally, we'll also talk about options that you have for the implementation of your strategy. And this essentially takes all of the points that we will go through and gives you some key pros and cons to different implementation strategies. As we go through all of these considerations, we'll be kind of working with an example scenario of a company that it may be like yours is going through the process of implementing a mobile micro frontend strategy. And so in this kind of fictional scenario, we have an organization that has an e-commerce app. As they're moving into implementing a mobile micro frontend strategy, they have 5 teams that contribute to this app. There's an iOS team, an Android team, and then 3 specialized web teams that work on different core functionalities, essentially what makes up these micro front ends. They build for the web. And at this time, the native teams are starting to incorporate web micro front ends into their iOS and Android apps for efficiency. They've started to implement this process from the development perspective and are going to get kind of caught up with some scenarios and deployments as we go through this session. They're still in the process of implementing, and so they may see some scenarios that you may have also seen in your own implementation process, or things that you may encounter if you decide to move forward with a mobile micro front-end strategy. So we'll be covering all of these different considerations through the lens of this kind of company in this scenario. All right, so to get started, let's talk about organizational considerations. So we often say that micro front-ends, it's not just architectural, it's not just technological. It is really a business decision, an organizational decision. It does require multiple teams working in parallel to function autonomously, but also communicate to produce a cohesive experience for the users. At the end of the day, you want your end user to have the best user experience possible. So there's increased velocity when it comes to the development process, but there's also more moving parts. If you think about a high performance engine that can pick up speed quickly, that is able to handle like changes quickly with shifting gears, it may be a higher performance machine, but if you don't maintain it the right way, and if it's not configured properly, then that's when you may start to see issues. And it's the same when you're talking about updating a mobile micro front-end strategy. There are a lot of moving parts. There's different teams working autonomously and quickly, but making sure that those parts can work together for the ultimate goal of having a great user experience requires some planning and some configuration upfront. So some of the organizational considerations that you'll want to think about at your team. The first is team cultures. So are all the teams at your organization on the same page when it comes to app update frequency, testing, or any other types of strategy? And you may have an overall organizational culture, but depending on what parts of the application that the team is working on, they may prioritize different things. For example, if your app portion of the e-commerce app deals with transactions, you may have a stronger testing philosophy or be more strict about what aspects about updates that you push out because you're dealing with financial transactions, versus if you are working on a part of the application that's based more on drawing users in or creating a fun user experience, or maybe it's more visually appealing, you may be more open to experimentation, testing and production, leveraging A/B testing, or different strategies that are have a different type of culture, one of more of experimentation. So you don't necessarily have to have the same culture across teams, but understanding what those differences are and what those priorities are is important as you think about update strategy. Next thing to think about is knowledge sharing. So how siloed is the documentation, education, and other resources across your organization? If there is something that somebody working on one part of the team needs to understand about a micro front end, or if an update needs to take place in order to update how the native part of the application is connected to the web part of the application in the micro front end, how you're passing data back and forth, if an API is updated, is it easy for teams to find documentation and understand where they can go to look for that? I've worked at organizations where different teams use different toolings, had different processes, and knowing where to go to find that can be difficult. Another is design system maintenance. So if you are using a design system across your organization, how well do teams take ownership of updating and maintaining a shared design system? And you can apply this to any type of shared resource. So we talked about authentication, we talked about data storage, session storage, anything that is shared across the entire application. Understanding if you make updates to that, who takes ownership of that? How are those updates communicated? And how are decisions made in terms of what those updates look like? Then there's stakeholder decisions. So who is responsible for making decisions when conflicts arise across teams, and how are stakeholders informed of key updates? Again, this is not a technical implementation question at all, a consideration at all. This is entirely in regard to your organizational structure and how decisions get made. How quickly can decisions get made too? If a bug is introduced or a major update needs to take place, and there is a chain of command that moves more slowly than you would like, understanding that you may need some lead time or trying to increase that velocity to keep up with the development cycle. And finally, corresponding business units. So do all the teams work with the same business units for prioritizing features or implementing fixes? How are conflicting priorities handled? Again, you may have some teams that maybe take direction from internal users who need to have certain functionality turned on from an admin perspective. You may have some teams that work more closely with marketing or business teams that may want to make changes to highlight for certain promotions that are going on. You may have teams that work more closely with data security because they involve user information and have certain compliance requirements. So all of these individual pieces of engineering teams may work more closely with some business units than others, and understanding those relationships as well is going to be critical for how you decide when updates get pushed out. So let's take a look at a potential scenario regarding organizational considerations for an update strategy. In this case, the native iOS team has updated a card component that's used for their product list in their e-commerce application because they'd like to better highlight sale items and a discount amount based on business unit feedback. However, the updated design is significantly different from the existing product card used in the checkout flow. So I'm going to throw this to the chat. I'd like to kind of get some thoughts on, as an organization, how do the teams work together to ensure a cohesive UI for the users? So there's a few different strategies and solutions that you could take to solve this issue, and I'm curious what some of y'all have seen or how you would approach this scenario. Give a few minutes here for people to answer in the chat. All right, so seeing some responses, and again, in the chat, you can respond to either everyone or to hosts and panelists. So seeing some answers here, not everyone may see them though. Okay, great. So definitely seeing some responses around having a robust design system. And then, yeah, so Stephen says, this is a great one. You need a design system as a base, but you need to add the ability to have different design templates. Then that can be selected and added to the catalog of configurable options. This will give you the most flexibility. Thank you so much for that, Stephen. So just give it another minute to see if anybody else has any other solutions for this scenario. All right, so here are some ways that you could approach this. The first one actually aligns with what Stephen said. So leveraging what we call design tokens for cross-platform cohesion. Our design tokens are a more abstracted out way of implementing a design system. So yeah, you could have different design templates. You could have essentially these aspects of your design system that will work no matter what platform that you are on, and maintaining that across iOS, Android, and web. Gives you that flexibility to be able to adjust them as needed for each platform without interfering with other teams are doing. Additionally, what I've seen some teams do is they will style the web components to catch up with the native updates because they're a little bit quicker to update and push out. So the web team may follow suit from the native team's update. And then you may also decide that going forward that you would rather leverage the web micro front ends or web components for the majority of your, leverage web micro front ends for the majority of your UI components for efficiency. So you may decide that instead of having a component in the native application, just leveraging web in as many different places as possible so that you can reuse that rather than having it be having UI components live across platform. All right, so now let's take a look at infrastructure and architectural considerations. So when we talk about architecture and infrastructure and architectural considerations, this is essentially where development meets DevOps. So organizations may have different deployment strategies between web and mobile. In fact, they most likely do. Web and mobile deployments are not the same. So what you may see is dev teams may own their own deployments. For example, the iOS team may have an expert on the team that is responsible for manually pushing those updates out to the App Store. Same for Android, and then web may leverage a CI/CD system, but that may be owned by the web team. Another option that you see is having a centralized DevOps team that actually will provision the resources for deployment across all platforms. This requires the different teams to work with that centralized team in order to ensure that you have the correct infrastructure and build assets available in order to deploy out your updates. So regardless of which structure that you use, there are specific considerations that you need to keep in mind. So let's take a look at those. The first is repository structure. So the question comes up: monorepo, polyrepo, sync, no sync. This is a question that, again, is not it requires a technological implementation, but it is still a strategic question. So how will your code bases be organized and stay in sync? You do have the option of, again, syncing, keeping everything in the monorepo. You have the option of syncing other repos to a main native repository in order to build your code. You have the option of keeping everything separate. And a lot of that will also depend on your update method. This is essentially whether your updates will happen at build time or at runtime. So when we say updates for your mobile micro frontends happen at build time, that means that all the code is developed for your micro frontends separately, but then when it comes time to actually build and deploy your native application, all your web micro frontend code is synced to your native repository and then built as one. This means that anything that happens after that deployment will not be updated in that version of your mobile application. Again, mobile applications have to be built and deployed to the App Store in a single version. So if you're doing that at build time, all the updates are going to take place together. The other option is, again, at runtime. This is going to more closely mimic what you may see with a web micro frontend solution, where you may be using embedded web views in order to call out to either a live server or a CDN in order to access any web micro frontend code, and that is embedded inside your native application. There are pros and cons to each method, and each option has infrastructure requirements. If you are doing build time updates, you would need the infrastructure to build your mobile app regardless, but you will need to set up infrastructure in order to ensure that your code is synced if you have multiple repositories. And at runtime, if you're doing runtime updates, you will need to ensure that you have infrastructure set up, either being servers or CDNs, to deliver that runtime content. You also need to think about environments. So how will dev, test, staging, any build environments, how will they be provisioned? Will you maintain infrastructure in-house? And how will dependencies and build stacks be managed? So if you have different development dependencies that are required in order to build out your micro frontends and test them alongside native, if you are running a dedicated testing environment for everything compiled together, or if you're testing everything separately, all of that takes infrastructure that needs to be established and maintained. And whether you're doing that in-house or whether you're utilizing a solution is another decision that needs to be made. We talk about testing. Obviously, testing mobile applications is more complex than testing web applications. So when you think about your test infrastructure, it's not only going to involve building out the web micro frontends, but understanding what types of devices that you're going to be testing on if you are going to do end-to-end native testing, and how you're going to provision those devices. Then there's automation. So we're going to talk about this a little bit more in the implementation strategies section, but thinking about what aspects of the deployment process will be automated. Will you have some teams that deploy more manually? Will you have some teams that deploy more automated? Or will everybody follow the same process and need the same type of infrastructure? And then access management. So this is a little bit more of it's more of a security consideration, but it is related to infrastructure and architecture. So which teams will have access to tools, security credentials, or infrastructure needed for builds and deployment of updates. For example, in order to build native applications, you do need to have signing certificates set up for code signing, and you need to have access to developer credentials to deploy to the app stores. Will web teams have any access to those systems if they need to do any specific types of testing, or will they be completely autonomous and everything gets funneled through one team? Those are things that need to be defined out to understand the access management. You may have you set up different types of roles for different teams, or only give access to certain teams to certain tooling. All right, so let's take a look at a scenario regarding infrastructure and architectural requirements. So the web team is set, all the web teams are set up with CI/CD, and they push changes to their micro front ends multiple times per day. Anytime that new code is ready to be deployed, once it passes its tests, it gets deployed out and is live. Again, these are web micro front ends are used in the web, but then also are being ingested by the native applications. Because of that, the native teams still have a manual deployment process as they're in this process of implementing micro front ends. They release 1 to 2 times per month. They do a manual deployment process. It takes some time to do that. They don't have CI/CD set up. So native teams are using a build time strategy, and they're incorporating their web micro front ends during the release time. So this creates large, complex releases and causes the native team to have to catch up to web. They essentially need to get them, they're always receiving the latest version of the web micro front ends, but may need to establish what has been updated, if there's any dependencies that need to be updated, or anything that needs to be configured to ensure that everything is working cohesively for the new native version update. So throwing back out to chat, as an organization, how can the native teams improve their update velocity and make releases more efficient? So I'll give them a few minutes here for people to post in the chat some ideas of how they would approach making the native team deployments more efficient so that they can better incorporate web micro front ends. All right, looks like Stephen definitely has some experience with mobile and native, with mobile and web DevOps. This is another great answer. So we centralized a DevOps team that would manage both web and native, since it will require orchestration. And that's something that definitely requires some expertise. Just give another minute, see if anyone else has any other solutions they'd like to present. Getting Apple to make the approval process faster. I'm with you, Ricardo. I would love that to happen. We talk a lot about how, you can only go so fast with mobile deployments because you are limited by the store processes. I actually have seen also Google Play Store take a long time for initial improvements, and they do require you to upload the very first version directly into the Play console, which could really slow down initial release. So. All right, so we'll go ahead and take a look at some strategies that you can use. So one is, throw more resources at it, right? Dedicate more resources to native releases to increase the frequency of native app releases. So deploying 1 to 2 times a month is very common across the industry for mobile deployments, but it's not ideal. We can see teams that deploy much more frequently, again, dependent on App Store approval, but we have seen teams that will release more at a cadence of a couple times a week. And so if you are able to improve the frequency of native app releases, that can make the releases smaller and more efficient. However, that may not be the most realistic strategy for your organization. So one other strategy that you could use is going from build time updates to runtime updates. So you could decide to use something like embedded web views for iOS and Android to access your web micro front-end content at runtime. There are definitely some limitations to using built-in iOS and Android web views for this type of setup. There's network delays, understanding the passing the data between the web view and the native app needs to be kind of built out of the box. but that is a potential solution that you can make in order to increase the velocity of the releases. And then another strategy that you could use is to use a solution like Portals from Ionic that allows for autonomous updates across your micro front ends for your mobile applications. So with a solution like Portals, you are able to push updates to the web portion of your application, the micro front end, separately without needing to push an update to the native application itself. So the native team and the web teams could all deploy autonomously and work together without needing to bundle everything at build time. You're still doing build time releases for your native application, but any changes that happen to web could be pushed separately. So by the time a new native version is required to be released, those have already been incorporated for the user, and there's less of a update experience that takes place. All right, so now let's talk about process considerations. So when we talk about process, we're referring to the actual steps and checks that will occur to ensure that your updates are successful. You can have shared or individual processes across your team, but to best leverage the benefits of micro front ends, you need to balance independence and cohesion. So the first process consideration is version compatibility. And again, this is why I'm glad that we had so many great questions for Luca, and he was able to answer some of them. But how will you ensure that micro front ends and native app versions are compatible? So if you do have updates that are required to any APIs that involve how the information is shared across your micro front ends and your native applications, understanding what version your micro front ends are on, understanding what versions of your micro front ends work with what versions of your native application. There should be steps in your process to update to ensure that you're still supporting any legacy versions of your application that may be out there, unless you are going to force an upgrade of the native application to your users. And that leads us to update delivery, right? So there's different ways and methods to deliver updates to your users. Some of them require a user to stop using the application and update a new version. I know I've been on my banking app or different apps and it says, stop, you must download a new version, you cannot continue. Other times you will receive an update in the background and it will be loaded at the next installation or open of that application. So what delivery strategy works best for different teams, right? Maybe Android and iOS may have different strategies. Maybe depending on what the update is, you will force an update, but if you are making an update to a micro front end version only, then you may allow it to be in the background. So understanding how you're going to handle update delivery and if that will work across all the teams is something that you think about in your process. What we recommend at Appflow is for updates to take place in the default background mode for any of our live updates that are pushed out in order to have a good customer user experience. All right, and then so testing. So what amount of integration and production testing is required? And so we talk about integration testing. This is testing that is done before deployment, and then testing in production is obviously testing in production on actual devices. And those could be internal devices, they could be beta users, they could be actual production users. You can use different strategies like Luca mentioned in terms of reducing the blast radius by rolling out things in stages or using canary releases. And if you are able to deploy to different types of channels for your mobile application, you can have testing on actual devices as part of your overall testing strategy. If you are doing more integration testing before deployment, then you'll need to, we talked about that in the infrastructure section. But from a process perspective, what is the minimum amount of testing that's required? Do you have code or case coverage requirements that need to be fulfilled before you can deploy? And then rollbacks, how quickly can critical bugs be addressed? Do you have a recovery strategy? Do you have SLA requirements? If there is a critical issue, what is your process for ensuring that that can be fixed as quickly as possible? and measurement and monitoring. So I'm really excited that observability came up during some of the questions for Luca. So observability is something that is really important for measuring and monitoring things that like errors, performance, and usability of our applications. And when we talk about measurement and monitoring, monitoring refers to things that we know. So this will be things like having defined error messages that we are keeping track of, having defined performance metrics that if we exceed that, we become aware of, versus observability, which is more about gaining data for things that we don't know yet, the kind of unknown unknowns in order to identify patterns that could help us improve our applications. So when you think about how you're updating your strategy, you also want to think about, am I making updates to any new error classes that may occur, and are those being monitored appropriately? And also, are we monitoring our micro front ends autonomously, or are we monitoring everything together as part of our native application? All right, so let's take a look at another scenario. Yeah, so Michael pointed out bugs in production and the ability to roll back quickly is massive. So that actually is very timely, Michael. Thank you for that setup, because our scenario is a critical bug is introduced into a micro front end that needs to be rolled back as soon as possible to restore app functionality for users. So, and yeah, so in this case, again, this will really depend on your update method. If you are doing runtime updates, right? This may be as simple as just rolling back the version of your web app micro front end, and then the very next time that application pulls down from that server or from the CDN, it will have the update. Yeah, Michael's a plant, sorry. And so runtime, that scenario becomes a little bit easier to handle something for rollbacks. But again, when it comes to runtime updates, you do have those infrastructure requirements. So you'd have to have all this set up in advance in order to be able to roll back. If you have build time updates, then if you're using something where everything is built at the same time and it's compiled together and is pushed out to end users, and you don't discover the bug until after it's already been deployed to the application stores, then you are stuck essentially with needing to do a new release. A third option is if you are using portals and Appflow, you can do instant rollback with Appflow and portals combined. So Appflow, as I mentioned, is the mobile DevOps platform from Ionic. It allows you to do cloud native builds and deploy to app stores. It also allows you to deliver web builds to receiving channels in order to update web content within your mobile applications. It works for capacitor applications if you've ever worked with those before. And it also works with portals. So if you're using portals with an iOS or Android, React Native or capacitor application, you can also deploy updates to your mobile micro front ends without needing to have separate web infrastructure and without needing to do a new release from the App Store. So let's take a look at what that looks like in action. So this is an example of our application. This is the e-commerce app that everyone's working on in our scenario that we've used so far. And the square in red is our featured products, and it is a micro front end. It's a portal micro front end specifically, and it's built with React. So this micro front end has a dedicated repository that is separate from the native application, and it's developed separately autonomously by the team. When the native application does a new release, the micro front end build output is synced to the native application repo. That native build occurs, and that's what is deployed to the App Store. So this is still a build time update for our native application. We are incorporating that web code and that build output when we build our native app. However, our portal is configured to receive live updates whenever there are changes deployed to the micro front end repository. So everything inside of that red square, our micro front end, can be updated with pushes essentially like over the air updates or live updates as we call them, whenever you deploy that to a specific channel. For demonstration purposes, this application will be manually fetching these live updates. There's a little refresh icon that I've circled in the slide. Typically, we do recommend pushing updates via that default background method. But for demonstration purposes, we're going to show you what that looks like when pulling those down manually. So how do we configure this in our application? So in our native code, I'm going to be using iOS here. We use the portals SDK. We add that key to our application, and we are inserting a portals into our iOS app. Here, what we're doing is we're defining a featured portal, which corresponds to our featured products application. And we have it's pointing to the directory where we have the build output of that code that has been synced from our micro frontends repository. So we are stating that everything inside of this portal is actually going to come from that build output on the web directory. Then within our view, inside of our iOS application, here we are using a reloadable portal, and we are pointing that to our featured portal name in our configuration. And again, we're using this kind of reloadable portal for demonstration purposes. You most likely would not use that in production because you'd really want the user to have the background updates. But for demonstration purposes, we're checking and we're fetching for any live updates whenever we hit that button. And Portals and Appflow does provide some different methods and for checking for updates and for handling those if you did want to do something that's more configured, such as this. We also have to configure Appflow live updates. And this is pretty straightforward. Back in our portal configuration, we are passing through our live update config. We're passing through an app ID, and this app ID corresponds to our micro front-end application that we've set up in Appflow. We're also passing through a channel. So I have this channel set to testing because this is code that is running on my local machine. I'm running this application in a simulator, and I only want to receive updates that have been deployed to a testing channel. So depending on how you are working with your application, you can actually use live updates to use different strategies for deployment. So you may have a production channel, that will deploy an update and it'll go out to every single application that is receiving updates from production. You may have a beta channel. You may have an internal channel. So you may have different versions of your app, maybe like a free version and a pro version. And so all of those can be leveraged by using different channels that are configured to receive different types of updates from your Appflow configuration. And then I just have sync on add set to false because this is a demo we're fetching manually. So let's take a look at what this looks like. So here in our simulator, we have the application running locally. This application is configured so the featured products micro front end is connected to this project in Appflow. So this is the Appflow dashboard. And here we have the project set up for our micro front end. I created this project by simply connecting Appflow to the Git repository that has the code for the featured products micro front end. And Appflow gives us an app ID that we pass through to that configuration in our native application code in order to connect these. And so in Appflow, you can see the latest commits to the repository for the micro front end, and you can create builds from any of these commits to deploy to specific channels. So I can deploy, for example, to production or to testing with the latest web build. You can also automate these builds so they deploy whenever code is pushed to a certain branch, or you can build them manually here. So here we can see the builds that we've created for our micro front end. Build number 2 is currently deployed to the testing channel. This is the channel that we passed in our native application configuration, and it's the same channel that our local application is subscribed to. And we can see here in our testing that the active build is build number 2. So when we go to our local application running in our simulator and we refresh, this web build number 2 is the live update or the version of that micro front end that we are receiving. So what happens if we introduce a bug? So let's go ahead and deploy a live update and see what that looks like. So for demonstration, I've already created a build here from a new commit that introduces a bug with a pricing color. So we can go ahead and click on that build, and we can deploy a live update, and we can assign that to our testing channel, which is the same channel receiving updates on our local device. So now when my application checks for a new update, I have deployed that bug and our price is gone. I accidentally updated the pricing color and we can no longer see it. But fortunately, we can easily roll back to a previous deployment instantly using Appflow. So if we go back to our destination and take a look at the testing channel, we can see that right now we have active build number 3. By clicking into it, we can see the deployment history of all the previous deployments, and we can roll back to any deployment that we'd like to. So I can choose the previous deployment number 2, which is the one that I know is just working, and I can go ahead and click on roll back to here. Once I do that, that build has been deployed, and when my device checks for a new live update, I can see that my price has been restored. So I was instantly able to roll back that change without needing to set up any kind of web infrastructure or needing to do a new update for the App Store. And again, we recommend the default background update method, but Appflow does provide you some options for configuration if you'd like to check things manually. All right, so let's talk about implementation options. So now we're going to take all the points that we just kind of went through and take a look at some big questions that you'll have when you go to actually implement your strategy. The first big question is obviously manual versus automated. So because mobile deployments can be complex, it's very tempting to manually deploy updates. But again, micro frontends are designed to increase velocity, and manual updates can slow down teams and reduce the benefits of micro frontends. So you really want to take that into consideration when you're deciding. But some of the pros and cons, for manual, it can create knowledge silos and single points of failure. So if you do have that one expert on the team who's doing all your deployments and they're not able to do that day, or they call in sick, that can create single points of failure. You also may have slower updates that counteract the velocity benefits of micro frontends. On the other hand, automated deployments do require a defined process and initial setup in order to define any triggers that are going to kick off automations and what the steps of those automations may be. If you're doing this in-house, it may require some YAML or some scripts in your Jenkins builds, but that's something that will need to be configured in advance. And also automated deployments do require maintenance. You have to make sure that you're maintaining build stacks or environments if you are using your own infrastructure. The other big question is going to be maintaining a solution in-house or using a third-party solution, so DIY versus a solution. So managing deployments in-house does typically require a dedicated DevOps team or a designated expert on each team. So I know, Steve, in the chat, we said earlier, one of the solutions was to have a centralized team that handles all of the web and native deployments because they did require configuration. This also requires you to have all the infrastructure provisioned and maintained. This includes iOS and Linux machines for your native builds if you're deploying to Android and iOS, servers if you're for live updates, or CDNs if you're doing runtime updates, and then any build dependencies for your native builds. Also for web builds as well. You probably have different dependencies for the different types of platforms, and keeping those maintained and making sure the environments have the dependencies installed as part of that pipeline. So mobile deployments and micro front-end deployments also each have their own set of complexity that require domain expertise. So when you combine the two together, having that additional level of knowledge requirement can be a little bit cumbersome, but deployment solutions can provide some advisory services, best practices, and resources if they're designed specifically for mobile and or micro front ends. So you can leverage that. But they may have vendor security or configuration requirements. They may have limitations, and then you may need to do specific configurations for your architecture that may not necessarily work out of the box. You also should always weigh the cost of a third-party solution against the cost of maintaining the infrastructure and personnel in-house. So regardless of which solution you go through, you'll want to take both of those factors into consideration. Awesome, so we covered a lot today. We had a lot of great questions. And so just a quick recap, we talked about organizational considerations, infrastructure and architectural considerations, and process considerations when designing out your strategy for updating your mobile micro front ends. We also talked about different scenarios that may occur, such as design system updates, having mismatched update frequencies across teams, and how to handle rolling back critical bugs. And we also talked about the benefits of manual versus automated and DIY versus solution, a third-party solution. So thank you so much for all your participation and answering questions in the chat. This has been Managing Updates in my Mobile Micro Front Ends. Again, you can follow me at Cecelia Creates on Twitter or GitHub. And I'll turn it back over to Vivek.